When faced with tough relationship decisions, people usually weigh their options mentally and come to a conclusion they best believe fits their priorities and values. But can a model predict or imitate this behavior? Through our project, we aim to gain a more technical insight into decision making within relationships. This is our team. While numerous industries depend on concrete analysis performed using elaborate technologies to optimize their decisions, the same process is not used for decisions related to romantic relationships. This could be due to the subjective nature of priorities and difficulty in quantifying aspects of a relationship. With an interest in how the gravity of romantic decisions resonates with the young population, exploring that link motivated us to look deeper into this project. Decision making tools are valuable and essential. Incorporating these tools in a way that can be used by anyone and everyone was another motivation for us. Hence, we introduced these tools to the world in a non technical context. Unlike more straightforward decisions like those in finance and business, decisions in romantic relationships usually don't have a price tag or monetary utility to maximize or a unit of measurement. When faced with tough decisions in relationships, people usually come to a decision that agrees with them logically and or emotionally. What factors drive these decisions? Is it possible to illustrate an individual's values and feelings as a numerical model and produce an effective and optimized decision? How does an individual's decision change as the situation becomes more complex? Our purpose was to address these questions. We had 4 goals in mind. First of all, to determine the role of personal values and principles in romantic decisions and how decisions change with increasingly complex situations. Secondly, to compare and contrast the outcome of psychological decision making against a decision making model. Thirdly, to analyze the effectiveness of the model in predicting the likelihood of an individual choosing a particular course of action. And finally, to explore whether individuals should depend on decision making tools when facing decisions in romantic relationships.
We will now go into the methodology. We aim to answer our questions through a case study of human response and decision-making in situations common in romantic relationships. Specifically, we will focus on the maintenance of long-distance relationships, communication in those relationships, and decisions regarding marriage. The first step is to perform a large-scale survey to understand what decisions an individual will make given a decision context and a set of priorities. Since priorities are subjective for each individual, the survey collects data on individual rankings of priorities in addition to the decision that one makes in response to that context. The next step is model training, in which we use a subset of the data as a training set to generate a logic model as our decision-making tool in this project. The ranked priorities in each scenario serve as independent predictor variables, with strong variables chosen as features in the final model. Finally, we analyze the results. We apply the model in the test set and analyze the predictions generated to gain insight into the effectiveness and accuracy of our model in capturing the psychological decision-making process mathematically. Diving deeper into the survey generation process, the format we presented scenarios in was the following: provide the decision context, have the individual assign values to a set of given preferences, provide potential outcomes, then have the individual choose a decision from a given list. We presented 3 scenarios to each individual, each one building off of the previous and with added complexity. The first scenario describes a long-distance relationship and asks the individual to rank these following priorities and choose a decision to commit to the relationship or to break up. Second scenario adds on an additional layer of complexity of deciding whether to pause communication with your partner, break up, or suggest a compromise in response to your partner's needs, with additional priorities to rank as listed. The third scenario adds on the decision of marriage, with again more priorities and different decisions to make. We successfully administered the survey through a Google form to 84 individuals, most of whom were in the age range of 18 to 24 years old. We then processed the data. Individuals had ranked each priority on a scale from 0 to 10, with 0 being not important and 10 being extremely important. To effectively compare rankings between individuals, we normalized the data so that the sum of each individual's rankings equals 100. This assumes that individual preferences follow the von Neumann-Morgenstern axioms of orderability, transitivity, and independence, meaning individuals can order and rank their priorities that follow these axioms, and their priorities are assumed to be independent of each other. With the data cleaned and processed, we first did some exploratory data analysis, including plotting heat maps of the features for each of the 3 scenarios. This helped us to analyze the correlations between features as well as to assist in choosing the strongest features for our models. That brings us to the model training. We decided on the logic model as a linear combination of an individual's value for each priority resembles one's subjective utility function. In addition, the predictions of likelihood from the model are nicely interpretable. For each scenario, we trained a model with a process first involving a train test split, with 80% for training and 20% for testing so that we could assess the model performance on unseen data. We randomly split the data while ensuring that the proportion of each class was the same in both sets. Next, we noticed that our data had heavy class imbalances, with one decision having many more data points than the other decisions for the scenario. So we tried out several methods of data balancing, including adjusting the weights of the data points and oversampling to create new data points for the minority class. Finally, we used cross-validation to prevent overfitting to the training data, using 5-fold cross-validation to select the best features for our model. With that, we now have our final models for each of the 3 scenarios. Here's a snapshot of the techniques and features used for each model. Regarding data balancing, for scenario 1, we found that random oversampling performed the best, so entries in the minority class were randomly sampled to become additional data points until it was the same size as the majority class. For the second and third scenarios, we used the synthetic minority oversampling technique, or SMOTE. This method draws a line between the examples in the feature space and randomly selects a new sample at a point along that line. After data balancing and cross-validation, our final models used these listed features.
Next, let's see what the model parameters are and the effectiveness of our model in predicting what people would do in the pro scenarios. So in scenario 1, you're faced with a decision of either continuing to commit to your relationship or break up with your partner, given that you're both forced to become long distance. So our model is telling us, for example, for every 1 year older you are 1.16 times more likely to commit rather than break up. And then if we look at the distance feature more intuitively, for every 1 unit one prioritizes their distance with their partner, they're 0.92 times more likely to commit rather than break up, which means they're actually more likely to break up rather than commit. And this is quite intuitive if you value distance and you guys became long distance. Scenario 2 builds off scenario 1, and here on top of the pandemic and long distance, your partner is suggesting to pause communication between the two of you because of work purposes. So here we would expect the features of communication and also how much you value your partner's time to stand out in this scenario. For every 1 unit someone values communication more, they're twice as likely to suggest to break up if we keep all the other features constant. And then the more you value your partner's time, the more likely you would agree to the request of no or less communication instead of breaking up. And we see these in the highlighted cells. Scenario 3 builds off the previous 2 scenarios, and now we've added pressure from family and friends, as well as the idea of marriage. So the features we'd expect to stand out here are how much one values their time, their partner's time, their family and friends' concern, and their own desire for marriage. Let's look at the your time feature. Our model is telling us for every 1 unit more one values their time, they're 3 times more likely to suggest to break up and move on compared to choosing the other 3 options, and half as likely or 2 times less likely to suggest marriage compared to the other 3 options. On the flip side, the more one values their partner's time, the more likely they are to suggest marriage or continue the relationship rather than breaking up. What's interesting and kind of unexpected here is that the model believes the more one values their family and friends' concern, the more they're likely to dismiss those concerns and less likely to break up and move on, even though we'd expect quite the opposite. So we do see some mismatch between our model and intuition here. Lastly, we'll run our model on our test set, and we get a 67% accuracy for scenario 1, 55 for scenario 2, and 44 for scenario 3. And as expected, the more factors and choices to consider, the more difficult it is for our model to make accurate predictions, which also resembles the psychological decision-making process in romantic contexts.
Given the model's functionality and results, we contextualize the data through its implications and limitations. The 3 pillars we depended on were effectiveness, usability, and qualitative analysis for implications. For effectiveness, we accurately identified which relationship priorities go into the decision-making process, and we identified the correlation with those priorities as well. We also found some accurate decision results. For usability, our model is best utilized as a reference for decision-making rather than a final ultimatum or final decision. The usability of it also recognizes the human-human relationship aspect in romance. Qualitatively, our findings showed that society tends to choose alternatives that allow them to maintain the relationship rather than splitting despite additional concerns. Concerning limitations, external factors, including time and intimacy levels, could have acted as confounders in decision-making. We had a small sample size which did not encompass enough data points, which impacted the model accuracy. We also generalized some scenarios which may not be representative of the dynamic situation in relationships. We had an age range restriction from 18 to 24, which is also not representative of the general population. To summarize, we sought out to create a simple and effective mathematical model based on individual values as utilities to predict psychological decision-making in certain romantic scenarios. To do that, we surveyed 84 people, we analyzed how those rankings affect the decision-making process in 3 increasingly complex scenarios. We used those rankings as utility measures, and we assumed that the individuals followed the von Neumann-Morgenstern axioms. Found out that as the complexity increases, the accuracy generally decreases. However, the model ideally captures many of our psychological intuitions. The implications of our model showed that it's yielded accurate results, which means it's a good tool to aid romantic decision-making. The limitations include sample size, generalizations, age ranges, and additional external factors. Throughout this process, we learned a few stuff. We learned that relationships cannot be standardized, the decision-making cannot be standardized, but it can be personalized to predict the decision-making. Found out that dynamic situations affected individual priorities, since priorities changed depending on the context. We found a visible correlation between decisions and priorities, which meant that as complexities grew among decisions, more factors came into play. Importantly, we realized that models can be built based on priorities to give personalized prediction direction towards rational decision making.
Looking towards future applications, we can improve the model through data collection by collecting survey responses from a larger and more diverse sample with age boundaries outside of the 18 to 24 range we focused on. We can perform more detailed feature engineering to determine the optimal features to account for in our model and include a wider range of scenarios to test all possible values. In terms of the model, we can experiment with decision trees, which would be relevant given the context of our project, try out the probit model, and also tune hyperparameters after further research. Finally, with a hybrid approach, we can consult with relationship experts or therapists to view their perspectives and discuss potential for a hybrid tech model. Thank you.